Alright, so let's move to the next chapter of the first module, that is ARM processor fundamentals. See, you'll have to talk about registers in this first thing. So if you see in the syllabus, you have register, CPSR, pipeline, exceptions, interrupts, vector table, code extensions, but we'll just talk about registers like general purpose register. See, from here till here are the you know uh, interchangeable registers in the instruction, and then here from here till here the special. It does not just much, you just have SPSR over here. Okay, just about the resistors, see they have spoken about that itself, so we'll just speak about those things over here. But before you start about talking about resistors, we'll just have a small overview about ARM processor fundamental. Then here ARM processor core overview. A ARM processor consists of functional units. See, it consists of functional units which are connected by data buses. See, it has one human architecture, single bus for data and instructions. A Harvard architecture, separated buses for data and instructions. You see, single bus, single bus, and here it is separated bus. Both have same functional, that is data and instruction. See, but we have about load store architecture. It uses load memory to register and store register to memory instruction. No direct memory to memory data processing. I told you that load is fetching, store is storing. Okay, key components: register file stores data values. Register file is basically register itself. ALU arithmetic logic unit performs arithmetic and logic operation. MAC multiply accumulate unit. See, multiply accumulate is similar to multiplication. It speeds up the multiplication operations. Simple, nothing much to Multiplication is basically done much. So they have mentioned about this. Barrel shift and nothing but shifting the value, bits in the register, like you'll be having 1 or 0, like long thing, you just shift like that. So you also studied about barrel shift in the earlier videos, why it is done before it is sent to the OS, so that it can be improving performance, something like that. Then this is a basic diagram which you have to remember for ARM core data flow model. They'll ask you literally to explain the ARM core data flow model here. So you just have to talk about all the resistors. You have to talk about address register separately, incrementer separately, ALU separately, barrel shifter separately. Basically, all the components which are present in this, you just have to talk about it separately. Okay, and then we have ARM register set. So ARM register set is nothing but general purpose registers. They are not 16 general purpose registers, each of 32 bit. So you can simply mention them as R0 to R15, like in a line, so that will take some space, and fill your paper. And then you have two program status register, that is CPSR and SPSR, current program status register and saved program status register. We will be talking about current program status register in the next upcoming series or section. It's very interesting. You don't have to worry or um, think it's complicated. All registers are 32-bit and they can store data or addresses. We have studied in the beginning. Special purpose registers. See, you have R13, 14, 15, SPSR and CPSR. So register their name and their function. R13 is the SP. You can remember them as SP. So let me just type it over here as CSP, and then I'll type another over here as LR. It's simple, right? And I'll type it as PC. Whenever you execute your lab programs, right, you can see this SP LR PC written in your output section. SP is stack pointer, link register, program counter. CPA current program status register, SP save program status register. So what are the functions of these things? It holds the top address of the stack. Stack pointer, see, you basically stack thing, right? So the top part, so whatever is on the top, the address of that is okay. Link register, it stores the return address during function call. It stores the return address during function calls. Program counter, it points to the next instruction to execute. Program counter basically see some instruction is being executed. So once the instruction is completed, it checks the program counter, which points or shows a direction towards the next what to say instruction. It's all about that. Current program status, it holds processor states, condition flags, and control bits. It's very, unique. All they have just said everything. All these things we will be explaining in detail when we go move on to the CPSR thing. SPSR saved program register. It stores SPSR when switching processor modes. So there are multiple processor modes. Okay, so register banking and processor modes. See, processor operates in multiple modes like user mode, supervisor mode. You actually have a whole diagram for that, but I don't know where it will be shown in the textbook. See, I don't know. Yeah, user mode, supervisor mode, system mode, undefined, interrupt request, fast, interrupt request, abort mode. It has its abbreviation, small letters. It has its modes, privileged or unprivileged. It's very easy. We'll be talking about that in CPSR, but right now, we'll be focusing about this current topic, banked register. Some registers are duplicated across modes for context switching. Orthogonality registers from R0 to R13, I mean R0 to R13 are fully interchangeable in most instructions, whereas R14 15 have special roles in subroutine calls and execution flow. R13 should not be used as a general register in OS based application. If we just have a look at this, see, R13 is traditionally used as a, okay, it's all. So I think this part you can simply like kind of ignore, or if you want, you can use it in your answer whenever you feel necessary. It's all for the toppers, but for us, what we just have to pass and move on, right? I mean, for you guys, not for me. So ARM follows the load store architecture. Registers act as intermediaries between memory and processor. Right? Load and so like memory to memory, it's not like that. It has a some side of right hand and left hand type of things, like a link between both the two things. And then we'll move on to the current program status register. Not now. In the next video. See you in the next video. It's gonna be very interesting. Just believe me, it's very interesting. I'll try my best to explain you the way I can. See you soon.